Hello and welcome back to another video with It's Dr. Dan, and today we're going to be learning about the conservation of mass. So what is it all about? Well, the conservation of mass is a law. So let's quickly refer to what is a theory versus law, just so we're familiar with those concepts. So a theory is a proposed explanation that is based on the examination of fact. So if you see a bunch of observations, you're measuring a bunch of things, and then you want to theorize exactly what it is that you're seeing. So this is something about like how maybe new medicines or new vaccines, or how maybe we can make rockets that can go to the moon. It's all trying to answer those why type of questions. Now, a law is something that's based on a natural process, meaning that it behaves exact same way no matter what, because that is how our world works. So, for example, the law of gravity, no matter what, if I take an object and I were to drop it, it's going to fall no matter what. So for this one, the law of conservation of mass is one of those. Now, what is this all about? Well, it's about that mass cannot be created nor destroyed via chemical reactions. So however much reactant you have going in or how much mass, you should get it out as a different type of product. So if you measure a certain mass at the very beginning and it combined with another ingredient that you measured too, you should get the same amount afterwards. Now, bear in mind, there could be all kinds of things that could go wrong. Maybe the reaction's not perfectly complete, but it is something that's been observed time and time again for as long as humanity has existed. It is a constant law that exists. Let's take a look at what this is all about. As I said before, this is all about how we can conserve mass, meaning that let's say if I have a reaction and I have a bunch of little atoms trying to go into this chemical reaction, and I want to ask what exactly will happen? What should I get out afterwards? So if I have 3 yellow atoms and 2 red ones, and they were to go through the chemical reaction as reactants, according to the law of conservation of mass, all of them should come out. Now, if it's a chemical change or a chemical reaction, so where we have change occurring and we can see that change where everything makes a brand new product, notice how I still have 3 yellow atoms, 2 red ones, but they look completely different because a reaction took place. However, I still have the same mass, because if I add up all those individual atoms, I will still get the same number. So atoms are rearranged during a chemical reaction. They are never lost. So they always exist as something, whether it's a product or a reactant, meaning that the mass of any element at the beginning of a reaction will always be equal to the mass of the elements at the end of the reaction. So if I have all these little pieces, you should be able to add them up and you should have the same amount of mass on both sides. So the mass of the reactants always equals the mass of the products. And so let's take a look at how we can use this in some examples. Let's say I have a combustion reaction, meaning that we're going to burn something. So similar to, let's say if you have a gas stove or a propane grill at home, you burn the gas and it needs oxygen for it to breathe in order for that to happen. Well, what does it make afterwards if you were to burn something? Well, one of the things that you might see or notice is smoke, right? So CO2. One of the other ingredients that can occur as well, it will be made as well as water, which you can see as water vapor out as well. It's one of the other things that gets created. So if I have a combustion reaction here, I have methane gas and I have oxygen atoms. Notice how they're all together, and it's going to combust and we're going to be making CO2 and water. Now, let's say we were to measure this reaction, meaning we're going to measure the mass of each of the different ingredients in it. So I measured it and I found that there were 16 grams of methane in the reaction. And I noticed that there's also 64 grams of oxygen, and it combusts to make CO2 and water. Okay, great. So we want to highlight all those important pieces of information as we go through these, right? It's something I've talked about in many of my videos as we go through them. Put the information together, figure out what you're given. Now it says we also measure 44 grams of CO2, which is created. Now I'm asking, or I desire, is how much water should we make after a complete reaction? So how much water should there be? Now, what are we going to do? I already have a balanced chemical reaction, which for many students at this point is something you will learn later in the semester. So we're going to write down all the piece of information that we were given. So we have 16 grams of methane, we have 64 grams of oxygen, and we have 44 grams of CO2. And we want to know how many grams of H2O do I have in this problem. Now, from this, if you remember from what I said before, the mass of the reactants is equal to the mass of the products. So what exactly should I do? So this is just simply just an algebra problem. We'll add up both sides and solve for x essentially, which is water. So if I take this and kind of rewrite it for ourselves, let's do that. So we have 16 grams of CO2, we have 64 grams of O2 as reactants, and that's equal to 44 grams of CO2 plus x. So let's solve for x. So on the left-hand side, we'll have a total of 80 grams. We will move over the 44 grams from both sides. And what we will see as a result is that x is going to be equal to 36 grams. So 80 minus 44 is 36. Now, does that make sense? Well, let's take a look at it. So if we know that water was 36 grams, which is H2O, and we know that CO2 is 44 grams, what is the total? 80 grams. And what was the thing that we had on the left side earlier? Well, if you notice, earlier we had 80 grams as reactants. So notice that the law of conservation of mass exists, and we have the same amount of mass on each side. So if you have a complete reaction, or even something that maybe it doesn't completely go through, if you measure everything, you should still have the same amount, okay? So this has been the conservation of mass. I hope that this video helped you. Thank you so much for listening, and please hit that like and subscribe button if you haven't. There will be more chemistry content to come, and thank you all so much. Bye now.